This is where
but I want to do this slowly and carefully. But some of the explanations on what is going on can be longer. It doesn't have to be hard what we're doing, but to understand enough for it not to be hard, you have to be willing to sit and listen through an entire explanation. You have to stay focused and engaged through the entire explanation. I will try to make this as easy as I possibly can and give you methods to do things so that the method can stay the same, but we really need to stay with the explanation the whole way through. Okay? If somebody stops me to ask me a question about something, it's really important that you also listen and stay engaged through the whole explanation. There may be things that come up that you're like, oh, yeah, I thought I understood that, but no, I guess I didn't. This is really what I want, how I want to think about it. I need us to do a little bit better job, especially during the lectures and explanations, of really staying focused through the entire thing, okay, all the way to the end. I will try to, again, give you as clear and general of a method that I can to do these problems so that you can kind of do the same thing every time. But it's not going to just be like solve for X easy problem like from Algebra 1. There's going to be some layer to it because there's going to be some geometric explanations for why we do things. That's what trigonometry is. Throughout the whole thing, we're going to need algebra skills, and there's going to be some geometric explanation of why we have to do it this way. Okay? So those two things get nested together, and it's really important that you kind of stay engaged through the whole explanation so you can see why the geometric explanation comes in for why we have to do something, and you can see how we're doing the algebra the other part of the way. Okay? So what we're going to be doing in 4.1 is talking about our inverse trig functions. So let's start with talking about sine, right? So let's say we have the graph for y equals sine x. I think this one can be challenging. Okay. So this is the graph for y equals sine x, right? Now, remember back to your Algebra 2 course, or even earlier in Chapter 1, when we talked about inverses. What do we have to do at some point when we find the inverse for a function? We end up having to swap the x and y, right? Something like that. Everybody's okay? So let's go ahead and graph that. I'm going to use this graphing software where I can graph things in terms of y, unlike your calculator that can't do that. So if I do x equals sine y, there's my function in the blue. That's sine inverse, or the inverse function for sine. What do you notice that's a problem with this blue graph? If that's sine inverse, what's the problem? Excellent. This blue graph fails the vertical line test. That means for any input, I'll have more than one output, right? That is a problem for us. So what we're going to do is we're going to restrict the domain for sine. So what we are going to do is we're going to say, okay, let's just consider the stuff from sine between negative pi over 2 and positive pi over 2. So now, yes. Well, I mean, just look at it, right? Like if I draw a vertical line, it's going to intersect that blue graph a whole bunch of times, right? That's okay? Okay. We just used our eyes, right? I didn't do any algebra, I didn't do any math. I just looked at it and said, okay, there's some vertical line like at 0 where it intersects the graph here and then there, and if it keeps going down again and keep, like infinitely many times, in fact, that we intersect. Ooh. Right? That's a problem. So what I'm going to do is I'm going to restrict the domain for sine. Notice our graph for sine now is just this green piece.
What is restricting it?
Well, what does that do? If I look at it, when I looked at sine of x, let's make that a different color. If I draw a horizontal line, how many times is that some horizontal line going to intersect that graph? Whole bunch of times, right? But if I take that green graph, how many times is a horizontal line going to intersect that? Exactly once. So if I take that graph and I swap the x's and y's, I get the blue graph. Does that seem okay? Yes, right? Is that a function? Yes. So that's what we're going to call sine inverse, is this blue graph. Okay? So if I look at, well, let's go back and look at that for a moment. So the green graph's domain, it goes from negative pi over 2 to positive pi over 2. And I picked those particular values because that covers the entire range for the sine function, right? If I look at this green graph, the range goes from negative 1. If I look at the y, everybody see that? To positive 1. I cover all the y's in my sine function with just this little piece. So the domain for my inverse, let's go back here. So if I restrict, okay, so if I do that, and then I do the inverse, the domain for my inverse is now going to be the same as, we're swapping x and y's, right? When we make an inverse. So the domain is going to be the same as the range from the other one, right? Because what coordinates are the range? The y's. So if I swap the x and y's, we have this, right? So we say for f of x equals sine x, f inverse of x is going to be, we're going to write as sine inverse of x, where the domain is -1 to 1, but its range is -π/2 to +π/2. And that's the part that's going to make what we're going to do in this chapter a little tricky. And we'll explain why in just a moment, okay? So let's say we want to find the exact value of sine inverse of 1/2. The first thing I want to check is that I'm plugging a acceptable value into sine inverse. So does 1/2 lie between -1 and +1? Does 1/2 lie between -1 and +1? Yes, right?
0.
So like if I,
Oh, you're just asking like.
yeah, it doesn't have to be midway in between, but it's somewhere in there, right?
Yeah.
So it's in, it's, yep, that's okay. I didn't mean, when I say between, I don't mean in the middle, just in between. Right? Everybody's okay with that? So this is an answer or a question that should have an answer to it. Everybody agree? So to answer this question, what I'm going to get out is my unit circle. Do you still have your copy of the unit circle I gave you? Take it out right now. If you don't have it, I have extra still. Need one, take and pass. Okay. If you don't need one, please don't take one. But if you need one, take one and then pass. If you don't need it, just pass. Okay, they're going around the room right now. While you guys are looking for one, if you find any of the previous tests that I've handed back, I think there's a unit circle on the back of at least Chapter 2's test, if you have that handy, if you can't find your unit circle. Or you can look on your computer, right? On the OneNote, the unit circle's in the Chapter 2 stuff. But if you want a physical copy and you can't find yours, please take one. And I'm just pausing here for everybody to have a chance to either get a new unit circle or find a copy of their old copy before I start talking so that you have something to look at while we're doing this. All right. So on your unit circle, what do the coordinates mean? What is the x coordinate on our unit circle? Cosine theta, and the y coordinate is sine theta, right? If you don't remember that, or you want to write that on your unit circle, write that on your own unit circle so you remember. So far, so good? So what I'm going to do now is I'm going to look at my unit circle for all the places where the y coordinate, because we're looking at sine inverse, is 1/2. So I see that happen here, and I see that happen there. Is everybody okay? Those are the only two spots on my unit circle that I see the y coordinate is 1/2. So that should tell me that sine inverse is either 30 or it's 150. Or actually, I should say, we're doing radians. Should be either pi over 6 or 5 pi over 6. Is everybody okay with that? To decide which one that I want, I have to look at if it's in between negative pi over 2 and positive pi over 2. So 5 pi over 6, let's start here. Is that between negative pi over 2 and positive pi over 2? If you can't tell, what if we think about it as decimals? 5 pi over 6 is like 0.86 or something. So is that in between?
Yeah. Pi over 6.
Pi over 6 would be over here, right? Everybody agree? Not in between, right? Too big. Because 0.86 is bigger than 0.5.
No, 1/6.
1/6, yeah, the other one will work though.
Yeah.
Yes. This one is good. So that's going to be our answer here. Now, did I really have to show any work to do that?
No.
No. I just looked up the value from the unit circle and had to make sure I picked the appropriate value. Let's do another, yeah? What if we want to do, say, I'm just going to write it over here, sine inverse of negative root 3 over 2. So I'm going to write this stuff in blue now so that we can tell, without erasing the whole unit circle, you can tell it for a different problem. So what do?
Find it.
I go to the unit circle and I look at which coordinates?
Pi over 3 and 2 pi over 3.
I look at the y coordinate. Oh yeah, first I need to check to make sure this is between -1 and +1, right?
Yes.
What is that? What is that decimal? Negative square root 3 over 2. Is that in between -1 and +1? Can you tell? How could you check if you weren't sure? What?
It's not.
Well, you type it in your calculator, right? To see what the decimal is. But yeah, and then we're checking on a number line. Sure. So if you're not sure what that is, or if that's less than 1 or bigger than -1. So that seems okay to me, right? Everybody agree? So this is an okay one to look for. Let's go and see if we can. Now, am I looking for this as an x coordinate or a y coordinate? A y coordinate. So I'll go to my unit circle. And I see exactly 2 places where the y coordinate is -√3/2. So my answer should be either 4π/3 or 5π/3. Everybody agree? What's up? You're good? Okay. Is everybody still following? Again, I'm taking a long time to do this and going slow because I don't want to leave anybody behind. So if you're getting bored or antsy, it's like it is taking forever. They won't take this long once you start getting good at this. So let's look at 4π/3. Is that in between -π/2 and +π/2? No, says Reese. Is it too big or too small? -π/2 and +π/2.
No.
He gave us it. It's given. In the thing, he gives us that. It's a given.
Ava.
This entire thing.
Okay.
Is this the -1? Is that like
No, this is the
like when sine was 0, function and cosine was like 0, 1? Is that like the same number?
No.
I'm so confused.
Can you scroll down to that problem?
Confused.
What the problem looks like?
This is what I wrote. I just wrote it here.
So is that a problem?
Yeah.
Okay. Sorry.
Okay. Nora, you say you're so confused. I'm sure other people are at the same spot.
Yeah.
Let's back up then. Okay. Where did we lose us? Where did I lose you at? The start. Okay.
Using the unit search
Yeah, because
figuring out if it's in between the two, or like, I don't know, I'm just confused.
So what I'm doing is I'm doing one thing to start. I want to check to make sure that the number I'm trying to take sine inverse of is in the domain of the function so that it will work. So I need that -√3/2 to be in between -1 and +1, which I just typed it into my calculator to check. It was -0.866, so it's fine, right? So it's fine. So then I'm going to go to my unit circle, and I'm going to look, because we're looking for sine inverse, I'm looking at the y coordinates that are equal, or that are -√3/2, and I see that happen twice. Okay? So my 2 prospective answers look like they're going to be 4π/3 and 5π/3.
Yeah, I think that.
So now we're going to check to see if either of those 2 answers land inside the range of the function. Like, are those actually acceptable outputs? Are they between -π/2 and +π/2?
Is it always the range I'm looking for? I'm not the domain.
it's the same.
So the domain is the checking
Right
your.
now, we're only
I'm going to answer this. You just didn't give me a chance. So the domain we use to check the input, the number inside. The range we're going to use to check the output, what it equals. Okay?
Yeah.
Is that
Yeah.
all right?
I got it.
Okay. Ava.
Okay, so like we do the domain, first, right? The first number line.
Uh-huh.
And then once we get that, once it's between that, that's like the first step.
And that's just a check to make sure the problem is doable,
So
right?
if it's not doable, then we just write like no solution.
Then then it has no solution, it's undefined.
And then once you find it on the wheel, you go to the
Well, we haven't finished this yet. So I'm still, like, this gets a little bit more complicated. So I want to finish this one up. And I'm happy to let us go through this again. But since we're not even all the way through this yet, I don't want to, like, this is how we do it yet, because there's a hiccup here that we still have to address. Okay? So we're checking, right? We have 4 pi over 3. What is 4 over 3 as a decimal?
That's one.
That's like 1.3, right? Everybody agree? That's too big, though. That's bigger than a half of a pi, right? Than 0.5. Everybody agree?
Yeah.
And 5 pi over 3, what's that? That's like 1.6, right? It's like 1 2/3. That's too big also. So neither of these work? Not so fast.
Oh.
it does work.
Well, both of these are too big, right? Neither of these two angles work. But what if there's an angle that has the same position on the unit circle as one of those two angles, but does lie between negative pi over 2 and positive pi over 2? Do you remember what those kind of angles are called? Angles that have the same position on the unit circle. We talked about them in chapter 2. Starts with the letter C. Not complementary.
Coefficient.
That's the number in front of a variable. Cotangent's a function.
Cosine.
That's a function also. What? Somebody said it. It's coterminal. Coterminal.
So negative 120.
You're just not negative 120 because that's still too small.
That's too small.
But yeah, that would be the coterminal of this one, sure. But it's so. How do we find angles that are coterminal? You either add or subtract 360, but if we're in radians, we should be using 2 pi. So let's check that. So let's take the first angle we looked at, 4 pi over 3. Should we be adding or subtracting from this? Subtracting. Why subtracting and not adding? Because 4 pi over 3 is too big, right? We need an angle that's smaller, so we need to subtract.
Yeah.
Okay?
Are we still on the one with the negative pi over 3?
You mean negative square root 3 over 2? Yes. We're doing this. And then we'll summarize at the end here. I know I'm taking a long time to do this, but it's because we keep, like there have been a lot of what if questions that have come up along the way, which is fine, but hang with me until the end and then we'll summarize the whole thing. Okay? To subtract 2 fractions, what do we need?
So the same denominator.
Good, a common denominator. So if I think about this as 2 pi over 1, what would the common denominator be between 4 pi over 3 and 2 pi over 1? 3. So let's multiply the top and bottom of that fraction by 3 over 3. So I have 4 pi over 3 minus 6 pi over 3. So when I subtract those two fractions, what do we get? negative 2 pi over 3. As a decimal, that is negative 0.6 repeating. Is that too big or too small? Now that's too small, right? Because it's less than negative pi over 2. So this one, not going to work. Let's check the other one. We have 5 pi over 3. That was too big. So should we add or subtract 2 pi from this? Subtract, because it was too big. We need to make it smaller. We'll make a common denominator the same way. That gives me negative pi over 3, which is negative 0.3 pi. Is that between negative pi over 2 or negative 0.5 pi and positive 0.5 pi?
Yeah.
It is. So this is what the output's going to be. Yes. I think that gets it all on there now, right? So let's just pause for a minute and then we'll summarize, okay? Because some people are writing, and it's hard to write and listen at the same time. Okay. So let's summarize now. Yes? Okay. Actually, before we summarize, can I point something out? We know that the range for this function was negative pi over 2 to positive pi over 2, right? If I want the angles between 0 and pi over 2, where do those angles live on the unit circle? Where do these angles live on the unit circle? What is pi over 2 in degrees the same as?
No, it's 3/6.
90. Right? Because you multiply by pi or 180 over pi. I'm sorry, yeah, 180 over pi.
Oh, yeah, 2 pi.
So that means that you're looking at those angles, right? Everybody agree? If we look at the stuff between negative pi over 2 and 0, that's negative 90 to 0. Where do those angles live? How do we do a negative angle? We go the reverse direction, right? So that would be those angles, right? Starting at 0 and going backwards 90 degrees?
It wouldn't be in the other spot.
Correct.
Pi over 2.
Would not be. That's the spot. So really, when we're looking at sine inverse, we only need to consider that half of the unit circle. Okay? If our angle is on the top half, so if we're up here, that's it. We're done. We just write down the answer. If we're on the bottom half, what do we have to do?
Check it.
We're just going to subtract 2 pi. We're going to find the angle coterminal to it. Okay? So to summarize, we first want to check to make sure the problem is doable. So is the number we're doing the sine inverse of between -1 and +1? Easy check, right? You just basically said bigger than 1 or less than -1. Easy to check that. Then we go to the unit circle. We find the y-coordinate in quadrant 1 or 4 that is the same as the input for our sine inverse. If you're in quadrant 1, the angle that corresponds to that point is your answer. If your angle's in quadrant 4, the angle that corresponds to that point, you need to subtract 2 pi. And then that's it. So let's look at that.
So why would it be negative pi over 2 comma 0? Why would it just be 0?
Because you always go small to big, right? When you write your interval, it's everything between -90 and 0. So it's saying like -90 less than x less than 0. If you write it the other way, that doesn't make any sense because there's nothing that's smaller than 0 but greater than -90, right? Or anything that's bigger than 0 but less than -90, right? This means this inequality, right? That means the same thing. That's just what that interval means. So stuff between -90, it's got to be the stuff bigger than -90 but still less than 0. If you write in the reverse order, the stuff bigger than 0 but less than -90, well, there's nothing. There's nothing that does that. So that's why we have to write it in that order rather than always small to big. Okay? Let's do one more example with our streamlined process to see if we can do this real quick, okay? All right, make one more here. And this time I'm going to do a green. So sine inverse of -√2/2. First thing we do, let's check -√2/2 and make sure it's between -1 and +1, right? When you're typing this into your calculator, make sure that the division isn't underneath the square root. I just wrote it down there. It's okay. So what does that say? Everything's okay, right? -0.707, definitely between -1 and +1.
Yeah.
So we'll go to our unit circle. We're just going to look in quadrants 1 and 4 and look for the place where the y-coordinate is -√2/2. I see that right there. The corresponding angle to that point is 7 pi over 4. But since we're in quadrant 4, what do we have to do with that? Subtract 2 pi. And when I make my common denominator and do all that jazz that I'm just going to skip, I get negative pi over 4. Which is how long that problem should take, right? Once we're good at it, that's how long that problem should take. Is that okay with everybody? All right. What do we still need to do, though? How many trig functions have we talked about so far? Well, really, 6, right? Sine, cosine, tangent, cosecant, secant, cotangent. Really 6. But we definitely still need to talk about cosine and tangent, right? Because we know that cosecant, secant, and cotangent are just related to sine, cosine, and tangent. So, but we definitely need to talk about cosine and tangent, right? All right. So rather than like show you where the inverses are coming from, let's just write down what the domain and range for those inverses are, and then do some examples. Okay? So if we have cosine, the inverse function for cosine, the domain here is going to be, again, -1 to 1, but the range is going to be from 0 to pi. And if we have tangent, the inverse there is going to be tan inverse. The domain for this is going to be parentheses pi over 2, or -pi/2 to pi/2. Oops, that's the wrong spot. The range here is going to be all real numbers, excuse me. And the range is going to be -pi/2 to +pi/2. Yes. This. So I'm going to pause here and let people that are writing stuff down finish writing stuff down. Then we're going to draw a little bit on our unit circle, and then we'll do some more examples. And then we'll assign one of these worksheets to work on.
So
I think. Let me double check here.
tan doesn't have the brackets.
Correct. Tan doesn't have the brackets. Ooh, I'm not even ready to do that yet. It's okay. What is the difference between the parenthesis and the bracket?
Bracket means that it stops. Or no, bracket means it stops.
Not quite. The bracket means that the number at the end is included. That's a possible answer. The parenthesis means the number at the end is not included, so that would not be a possible answer. Why does tangent have these parentheses here instead of a bracket? What does the graph of tangent have that the graphs of sine and cosine do not? What? Vertical asymptotes, right? Everybody agree with that? Remember when we graphed tangent, we had the undefined points?
Yeah.
Guess where on the parent function, where those undefined points occur? At -pi/2 and +pi/2. That's why tan inverse has a parenthesis at those values, because there is no y when I do tan of -pi/2. It's undefined. So I can't do tan inverse of a number to get pi/2 to come back because there's no number there. All right. So let's take a moment and look at this. All right, so we have our unit circle, right? And we wrote that the points on our unit circle are sine, comma, cosine, right? All right, so let's do this. And we're going to highlight quadrants 1 and 4 for sine inverse. this. And then we're going to highlight quadrants 1 and 2 for cosine inverse. And then we're going to do like a dashed on quadrants 1 and 4 for tan inverse. So that's where those guys live. You could just write down next to it like Q1 and 2, Q1 and 4, right? If you don't have a highlighter, that's okay. You know what I'm saying? You know? Right, you could do that instead.
So 1 and 2 is cosine inverse,
Yes.
and then 1 and 4 is tan inverse.
Yup. So let's do some more examples now where oops, that's not where I want that to go. Come over here. Come on now. So let's say we do cosine inverse of negative 1/2. Focus, please. Cosine inverse of negative 1/2. First thing I want to check is negative 1/2 an acceptable input? Yes, that's between negative 1 and 1. So what quadrant do I go looking for cosine inverse of negative 1/2? I look in quadrants 1 and 2, correct? Which coordinate, the x or y, am I looking at? X, right? Yes, Ava? Sine, I'm looking at y. We haven't done tangent yet. So our answer there is just going to be 2 pi over 3. So far, so good? That was okay, right? Will I ever have to do anything coterminal with cosine? Will I ever have to do that coterminal thing where I had to like subtract or add 2 pi if I'm using cosine inverse? No. No. Why not? Because the range for cosine is only positive values of theta. So we're good. let's do tan inverse. First thing I have to do is check to see, is -1 an acceptable input for tan inverse? Well, what are the acceptable inputs for tan inverse? All real numbers. So yeah, of course, anything you want, man. Go ahead. Okay. So, but how do I look for tan on the unit circle? Tan is y over x. So if I have tan of something gives me -1, what can I say about the x and y coordinates here? What can I say about the x and y coordinates if x divided by y equals -1? They just must be opposites of each other, right? Like one could be 5 and the other be -5. One could be 10 and the other might be -10. One might be -6 and the other might be +6, right? But they have to be the same number, just differing by a sign. Everybody agree with that? So what I'm going to do then is I'm going to look in quadrants 1 and 4 for a place where the x and y are the same number but opposite signs. Where do we see that happening at? Right here. Everybody agree? So 7 pi over 4, is that an acceptable output? Is it between -pi over 2 and +pi over 2? Oh no! It's too big, right? 7 pi over 4 is 1.75. So that's too big. So what are we going to have to do to it? Slim it down by subtracting 2 pi. I'll make a common denominator. I'm not going to show the work to do that. We're okay with that process. I did it a couple of times already. That's just going to be -pi over 4.
Did you get 7 pi over 4?
Because that's the angle measure that matches up with the point on the point where the x and y are the same number but opposite signs, right? Just like we did before, where I found the x was -1/2, so I used the angle that matched up with it, right? Does that? Okay. All right. We're feeling okay about what we've done so far? Let's do another kind of example now, and this is what you're going to be doing in your homework. Okay. So this is almost the same problem that we just did, right? Here I have, the directions are to solve for theta, write my answer in radians, and have it be on the given interval. So when I say the given interval, I mean between pi and 2 pi. Everybody's okay? All right. So what I'm going to do is get theta by itself by doing tan inverse of both sides. I'm going to now look at my unit circle. And I'm going to figure out where pi to 2 pi is. So if I look at my unit circle, pi starts here. And we go all the way to 2 pi that ends there, right? So this is where I'm looking for my answer at, is in quadrants 3 and 4. Okay, just like before, I remember that tangent is y over x. So I'm looking for the place where y over x is going to give me -1. So just like before, I'm looking for the place where the x and y are the same number but opposite signs. The only place that happens in quadrants 3 and 4 is here at 7 pi over 4. And I notice that that number is between 1 pi and 2 pi, because that's 1.75 pi. So we're done. Nothing else to do there. So when I do tan inverse the function, I always get something between -pi over 2 and pi over 2. But here I am solving the equation tan theta equals -1. There's infinitely many angles theta where I take the tangent of it, I get -1. The answer I'm looking for, I'm told, is the one that lies between 1 pi and 2 pi. So it's slightly different problem than what we just did, although it's using the exact same ideas. Are you okay? I don't think you liked my answer, but
No, that's fine.
okay. I like how you'll just go with it. It's like, I don't know if I like that or not, but like whatever you say, I'm not going to ask too many more questions about it. I'm happy. Okay, so here's our next problem, or next example. So again, our given interval here is from pi to 2 pi. So again, that's the same interval as above. So I'm just going to use the same color highlighting. If I do cosine inverse of both sides, we get that. Oops, let's do a different color, right? So if I go to quadrants 3 and 4 and look for the place where the x coordinate is positive root 2 over 2, there's only one location at 7 pi over 4, and that is still between 1 pi and 2 pi. So we're good. What if we have cosine of theta equals 1/2 between 3 pi and 4 pi? My first step is I'm going to go to my unit circle and figure out what quadrants are covered by 3 pi to 4 pi. So starting at 0, that's 1 pi, 2 pi, 3 pi starts here, and we go all the way to 4 pi. So 3 pi to 4 pi is still quadrants 3 and 4. Correct? Ellie? Certainly. 12:50. 4 more minutes. Yeah. So if I do this, I do cosine inverse of both sides. I'm going to look for the place where the x coordinate, because we're doing cosine, is positive 1/2. That happens right here. So my answer should be 5 pi over 3. But what's the problem? It's not too big, it's too small. So what's the solution going to be? Add 2 pi to it. So if I make a common denominator, I see it, Nora, just give me 1 second to finish this idea and I'll be right with you, okay? So that's going to be 6 pi over 3, so 11 pi over 3. And if I check that, is that between 3 pi and 4 pi? Yes, because that's 3 2/3, right? 11 over 3. So that's good. Nora, what's up? Yeah, of course. I'm sorry. How do you guys feel? Is this okay so far? It's not too bad. Again, this ideas that we're going and doing right now, really important. It gets more complicated as we go, but this is the foundation of everything that we're going to do in this chapter. If we're doing okay here, it makes what we do moving forward much, much simpler. Because eventually we stop limiting our search to unit circle values, so we have to start using our calculator. And we start looking at problems where you can have multiple solutions. So making sure we catch them all. So this can get a little bit detailed because of that. What I'd like for you guys to do as homework, though, is just this worksheet 1. So these are just like the examples of things that we've done here. Okay? So it's just like the problems we've just done, these last 3 examples. Hopefully this goes okay. Please try to do at least some of this before next class. It'll make a world of difference if you've tried a little bit of the homework before we start the next set of ideas. Okay? Any final questions for me before I say we're done? Okay. Great. Let's be finished.